So we are finally on the day 24. Now, I was very much eagerly waiting for this day. How many of you, put that into the comments, have been waiting for this day 24? Today, we have a very special topic. Almost every programming language, there's a chance of things going wrong. Every time you talk to someone, some developer, and he says that, hey boss, you know what? I write a code which never fails. If someone speaks like this in front of me, I say that you are the most dumbest developer that I've ever seen. Code are bound to fail. So the beautiful part is not, or the smartness is not in saying that I write a code which will never fail. The smartness is in that, how do you handle those failures gracefully? And that's where comes the concept called as exception handling. In this video, we're going to talk about that how in the world of Java, we have the different strategies of handling exceptions so that if something goes unwanted in the different direction, we are still able to handle that gracefully. Ladies and gentlemen, let's get started the world of exception handling today. Now let's get started and understand another concept called as exception handling, right? So let's first of all define a term called as exception. Now before we get started, just ask me one question from you people. Do you think, let's say that someone comes and tell you that, hey, you know what? I write a code which never fails. I'm such a great developer. If you get to hear these kind of statements from anyone, will you consider him a great developer? I'm not very sure about you, but if I hear such kind of statement from anyone, I really find that person real dumb. Because no matter what you do, sir, there's always a limitation to the code that you can write, and there are always certain unexpected circumstances where those code can fail. Fair? So the smartest is not in writing or ensuring the code that never fails, but smartest is in accepting the fact that anything that which you have written can go wrong, and then you are able to gracefully handle those kind of situations. So same thing in the world of the coding, exception means that typically when your code doesn't work as expected. And if your code has not worked as expected, what will happen? This will result in some kind of side effects. So smartest is that you accept that the code can go wrong. Code will not work as expected. And if that happens, when you go and take care of handling those kind of situations, you're able to handle those situations. That typically is called as the exception handling. That thing is called as exception handling. When you're able to handle the untoward situation, that typically is called as an exception handling. And why it is important? Let's try to understand with a small example. Let's say that you have written a code line 1. Right? So you have a statement 1, you have a statement 2, you have a statement 3, you have a statement 4, you have a statement 5, you have a statement 6, you have a statement 7. Let's assume that at this point, exception occurred. Now, if you have not handled exception well, what will happen in this case? This will go well, this will go, and at this point, since the exception has happened, all this point will not execute. But in the case, if you have some way been able to handle these exceptions, all these subsequent lines will be executed. So the next few minutes, we're going to focus around that. How do you go and define the exceptions? How do you handle that? And how do you come out of it gracefully? Fair enough? So let's get started and understand that what an exception is. But before we move further, there again a term called as an error. So sometime in the world of the Java and most of the programming languages, when you're going to deal with this kind of situation, two words will come very frequently. One is called as exception, and another word is called as error. Now, what is the difference between these two? Exceptions are normally the situations from which you can go and recover. Slight deviation from the expectation, right? So exception is something from which you can go and recover. Errors are something from which once it has happened, it can't be recovered. For example, let's say that in one semester you have multiple exams. One of the exams you don't get good marks. That's the example of exception. You can always recover in the next exam. Again, next exam, intermediate, you're not able to pass, you can still recover. So those things will be the example of exceptions. Let's suppose that final exam of the semester itself, you have bunked, you have not given the examination. There's no way of recovering it. You will have to redo the entire semester again. So that's the example of the error, right? Examples of the error could be, say, for example, hard disk crashed. Let's say that, for example, out of memory. Now there's no memory left. What can be done? Nothing could be done. Fair enough. Now, since we know that Java is an object-oriented programming language, this entire exception is again being done with the help of the classes and the objects, right? So if we're going to talk about the hierarchy of the classes, at the top of it lies something called as a throwable class. The throwable has two child classes. One is called as an exception. Another is called as an error. Normally, as a programmer, you should not worry much on the errors, because something from which you cannot recover, you should not worry much on that. You should worry more on the exceptions. See, everything is related to the real world. For example, in the real world, you're told that be careful so that you don't get infection, you don't get cold, right? You take care around that. But some untoward situation, for example, let's say that earthquake happens. There's no way that you can go and save yourself. So you don't care much. You don't live in the fear that earthquake will happen today and what will happen next. So those are the examples of the errors. So as a software engineer, you should not worry about error. You should be worrying about the exceptions. Now inside the exceptions, I have something called as an IO exception. Examples of that could be IO exception. There could be, for example, SQL exception. There is example of class not found exception, right? That's something called a runtime exception. A runtime exception example could be, for example, arithmetic exception. Fair enough. So these are the different hierarchies of the exceptions class that I go and talk about. You don't have to mug up anything, as we make progress, we'll try to do as much as possible, and that will get fit in our mind itself. Now we're going to talk about the exception types. There are primarily two types of the exception. One is called as a checked exceptions. Checked exceptions are those exceptions which has to be handled at the compile time itself. Compile time. For example, as we go and make the next move, when you try to read from the file. Now, when you're trying to read from the file at the compile time itself, it will throw some checked exception called as a file not found exception. Now, this is which we go and take care of at the compile time itself, are called as the checked exceptions. Then there are certain other types of the exception called as the unchecked exceptions. Unchecked exceptions are those which helps you at the runtime. For example, when you go and divide a number by 0, you don't know at what number let's say that the two numbers A divided by B. Now at the runtime only, if the value passed is equals to 0, it will throw an exception called as arithmetic exception. So these are the example of the unchecked exception. They are the subclasses of the runtime exceptions. So any exception which is not the runtime or the child of it, they fall under the category of the checked exceptions. Otherwise, they are the unchecked exceptions. So as we have done it, let's try to move to another concept, that how do we handle exceptions. Now, in order to handle exception, we use a concept called as a try, catch, block. What that means that let's say that we have written multiple lines of code, and we feel that okay, this is a line of a code which can throw exception. I want to be extra careful around this. So when you know that there is a specific section of the code which can throw exception where I have to be extra careful, what we do is that we try to go and surround that code with the try catch block. So we go and put something called as try, right? Which basically try to denote that this is a area or there is one of the code which has to be properly monitored. And then we put something called as a catch. So if something goes wrong, typically the catch part comes handy, and if everything is all fine, nothing goes through it. Let's try to understand this try catch with the help of a code, and I think it will make more sense to us. So let me quickly directly jump to my Eclipse. Okay, and let me go and define something called as public static void main. Public static void main string args. Now let's say that I have a number called as int data equals to a divided by b. Okay, and then I have int a equals to 15 and int b equals to 2. Fair enough. And this is the line of a code. If I go and execute it right now, sys out and print data, as of now, if I go and run this, boss, this will get me the answer 7. 15 divided by 2, 7. Very nice. If I go and change this b equals to 0 and I go and run this, I see that I have got a arithmetic exception, right? If I go and do a scribble here, you see here when I go and execute this portion of our code, I'm getting this exception called a Java lang arithmetic exception. So this line of the code is something which I would like to monitor better, so that if all goes well, there's nothing that I need to take care of it, but something goes wrong, I need to handle it gracefully. So what I do now is, this whole line of the code, I go and put that inside my try catch block. So I go and put a shield of try here. I go and say that try. And this entire piece of the code I go and put inside this try block. The try in itself does not do anything, it just creates a protective layer. But try alone doesn't do anything, as I said. If something goes wrong, I have to have some way to go and handle it. So to handle it, we go and make use of a block called as a catch. And inside the catch, I have to go and put that what kind of exception that I'm expecting. As I can see from here that if I don't do this, I'm expecting an exception called as arithmetic exception. So I'll go and write here arithmetic exception E. And then I go write sys out. And I go and say the e dot message. So if I go and run now, as you can see here, in Java the execution happens line by line. This A, B, I would have come here, come here. Here, as soon as I try to divide 15 by 0, it will throw an exception. What type of exception it was? As soon as the exception happens, the next line of the code will not execute. It will go to the catch block. It's arithmetic exception. And then I'm printing divided by 0. In the case if no exception is happening, in the case if this value is correct, let's say the value is 3, and I go and save this run again, I see the value 5 is getting printed. So if there's no exception, then this block does not get executed. So the try catch block, only if the execution involves an exception, it will go to the catch block. Otherwise, the catch block will not be executed at all. Let's try to understand another example. So let me go and comment this out. And let's put another example. Let's say that I have a string s equals to 1. Now, in the world of Java, there's a way you can convert one data type into the another. Say, for example, I want to convert string into the integer. For that, I have a method called as integer dot parse int, and I can go and pass s. and I go and call it as int my num. Now let's first of all put 1 here and do sys out, and I go and put the my num. If I go and run this is printing the value as 1. Fair enough, correct. Instead of 1, let me go and write it in the string itself and then try to do the same process. Now I'm getting the java.lang.number format exception. And it is also saying where it has happened. It has happened on the line number 8. This is the line number 8. And as soon as it happens, whatever that you go and write below this will not be executed. Now, since this line can throw exception, I can go and protect this line. I can go and put that inside the try catch block, right? So what I can do is that I can simply go and put a try block here. I can go and say that try. I can take this entire content inside this and then catch. And inside the catch, I have to go and tell that which kind of exception has happened. For here example, I go and see that the type of the exception is number format exception, which is in the Java lang package. Now, you don't have to mug up those exceptions. As we make more practice, we write more code, these things will automatically come in your brain. And I'm telling you, you don't have to put extra efforts to go and mug up all these, right? So I have to go and make use of number format exception. So I'll go and put here number format exception. I go and call it A, and sys out. Let me go and print here that inside the catch block. So if I go and run this now, it is saying that inside the catch block. So if I started executing here, at this point my exception will happen. This line will not get executed. Anything after that, and it will go inside the catch block. And anything which I go and write beyond the catch block should work as it is. So I go and say that sys out. This is the later line. So whatever that happens since after this will continue working as expected. So if I go and run this, it's saying that this is the later line. So this is, sir, how we go and make and screen a specific series of the lines under the try. Try doesn't come alone. With it comes the catch block, which helps you to go and catch the exception which can be thrown in those lines. Perfect. So far we have seen that the try block is basically used to screen a section of the code, and something goes wrong, the catch block goes and handle those exceptions. But it's not the catch block also, actually, if you don't write code well, that itself can throw exception. For example, inside this itself, after the number format exception, if I go and do something called as int result equals to 5 divided by 0. If I go and run the code here itself, this itself will give me the lang arithmetic. So I'm inside the catch block, but after this here the exception has happened, and if exception happens inside the catch block and it has not been handled, it will result in the same block. It will go and stop the execution then and there itself, and that's how you see that line number 17 which you see on the screen, this didn't get executed. You have not been able to execute this line because the exception happened at this line itself. Fair. Now let's try to move on. Inside one try, there could be multiple catch block also. What does I mean with that? Let me go and comment this entire code block as well. So if I go and select all of this, let me comment this out. Okay. So let's say that I have a array A equals to new int, and let's say the size is 5. Now I go and do that A5 is equal to 3 divided by 0. Now if I see here, what this means, a quick review, when I go and do this, this results that I go and create an array of the size 5, default value will be equals to 0. Now the value of the indexes here will be 0, 1, 2, 3, 4. Now when I go and put the element in the 5th index, this itself can throw exception called as index out of bound exception. This, when you go and divide by the 0, can throw the arithmetic exception. Arithmetic exception. these are the two different challenges that we have. So what we need to do is that we have to go and control this situation. And these are the two different types of the exception that can happen. So what we do is that we go and put this entire thing under a try catch block. So I go and take this code out, control X, put that inside the try block, and then I go and say that catch. First I go and write the arithmetic exception. Let me do one thing. Let not first of all put anything and see what happens if I go and execute this code. So I go and run this code. So first of all, I'm getting this exception called as at the line number 9, right? So this line is getting me this error. So what I go and do is, I'm going to put this entire code base inside a try catch block. And I go and say that catch, and then I have arithmetic exception E sys out, and I say that arithmetic exception handled. Fair enough. Still, if I go and run this section of the code is saying the arithmetic exception handled. Fair enough. If the arithmetic exception is not happening, right, I go and write it like 3 divided by 2 and run this. I still say that it failed. It's saying that now there's another kind of exception which is there, which is the array index bound exception. So if you don't catch the right type of the exception which has been thrown, it will give you the errors. It's just like, for example, let's say that your body is facing different type of infection. Now, infection could be created by different types of the organism. It could be bacterial, it could be fungal, right? So if you don't use the right antibiotics, your fever will not come down, your disease will not go down. Similarly, in the case if the exception is thrown and you're not handling it correctly, it might go and interrupt the entire program as it is doing right now. So here the another one is the array index bound of exception. So what we can also do is that we can go and apply the multiple catch, just like in the sometime doctors gives you multiple medicines with the hope that at least one of the medicine will work out. You can have a multiple catch blocks. So I go and say here catch, and I go and pass here array index outer bound exception E, and I go and say that sys out, and I go and say that array index exception help. And in the case the blanket exception, where let's say that I'm not sure which kind of exception it is happening, but if anything that goes wrong beyond arithmetic and the array index outer bound exception, I should be able to go and handle it. I go and handle it under the exception AXE E, and I go and say that sys out general exception handled. Fair enough. So if I go and run this now, I will say the array index exception handled. Fair. So like this, you can have, you can go and put inside a single try block, you can have the multiple catch blocks. And when you move from top to bottom, you should always feel that, you should have a smaller or child exception, which should be followed to the parent exception. Fair enough. Cool. Let's try to move to the next. Now, the next thing that we need to do is that sometimes, just like we have seen the nested conditionals and nested loops, the exception handling could also be done the nested way, right? So the nested try blocks. Let's try to see with the help of a quick code example. So for example, let's say that let me go and copy this entire thing. Right. So then I've commented this out. Now what I go and do with that, I go and write try, and then this is the outer catch. If you go and call it as exception A sys out any type of exception left. Fair enough. And inside the try catch, what I can do is that I can go and write another try block, and I can go and say that int b divided by int result equals to 5 divided by 0, and I can go and call it as catch arithmetic exception e sys out, and I want to say that inside the inner try catch block. Then I can get another try block, and here I want to say that int a equals to new int 5, and I want to say that a5 equals to 12. Here again I have to go and put the catch and the array index out of bound exception e here, and I go and call it sys out inside another catch block. Fair enough. So if you see here in the diagram itself, I have the outer try block and then our inner try block. This is called as the nesting of try blocks. Whenever you have one block inside the another block, be it conditional, be it loop, be it try, that's called as the nesting itself. Fair enough. So far we have seen that with try you can have at least one catch, you can have multiple catch, and the purpose of the catch is to go and catch the different and handle the different type of exceptions. Sometimes just using try and catch is not enough. There are certain situations, say for example, let's say that you are trying to connect to the databases. So in the case of any untoward situation, let's say there's some exception has happened, whether it is success or a failure, at the end of the day you would like to go and close the connections. Close the connections. Or say for example you're trying to read from a file, no matter you have been read it completely and clearly or you have done it with some issues, at the end of the day you would like to close that connection that you have done to read that file. So in order to handle those kind of situation, a code which definitely has to be executed no matter the exception has happened or not happened, that section of code is being executed with the help of something called as a finally block. How does that happen? Let's try to understand. So if I go to my Eclipse, right, and let me go and comment this out. Let me go and write int data equals to 5 divided by 25. What I'm going to do is that I'm going to put inside the try catch block. So I'm going to take a try. And then I have catch exception A, and I want to sys out inside the catch block, and then I have finally, and then I want to do something called sys out inside the finally block. So if you see here, this code, right, this finally is not like a method invocation, right? Finally is just a block of the code that is done. Now in this case right now there is no exception which is happening. So if I go and run this, it directly goes and executes. It executes this line, no issue. So it doesn't go inside the catch block, it directly goes to the finally block and it executes it. What happens in the case if there is an exception? So if I go and say that 5 is divided by 0, and if I go and run this, I know what happened. I came here, there was certain exception, So I go to the catch block, I go and print this inside the catch block, and then I go to the finally, I go and set that inside the finally block. So no matter what happens, exception is there, that's fine. Exception is not there, that's fine. But finally block will always be executed, right? So when you have a section of a code and you want that certain thing has to be executed no matter what happens. Exception happens, exception doesn't happen. You should go and put that inside a finally block. So with that we have understood the finally block itself. Now these exceptions that you see here, for example, when I go and write data divided by 5 equals 0, even if I go and remove this try catch block, right? Even if I go and remove this try catch block, it doesn't give any error, right? So this kind of exception which happens in the runtime, you don't have to care about when I'm writing the code itself at the compile time. These are called as the unchecked exception. So here what can come out is an example of a unchecked exception. But in the case if we write a code where there is a chances of a checked exception, it will not leave us relaxed how it is we are right now. Let's try to see with an example. So let's try to write a code which can throw some kind of checked exception. So let me go and remove this. And I go and call it as print writer. I go in PW, print writer belongs to the java.io package. As you can see here, as soon as I done it, I have imported the java.io.printwriter, right, from java.io package. Now I go and say that equals to new print writer, and I go and call it as something called as abc.txt, and then I go and add pw.print ln, and I go and say that hello students, something of this sort. If you see here, as soon as I go and call this pw is new print writer, I'm seeing this error. What is that? Let's try to click on this bulb icon. It says that as throw declaration surround with the try catch block. So as soon as I have, since I'm trying to write something to this file might not exist. So at this point it's trying to explicitly throw an exception which is called as a checked exception. And if there is a checked exception, I cannot go without handling it. There are two ways to do it. One of the way is that I go and put throw. So what happens? This is a method called as a main method. Inside this, there's a line of a code which has a chance that it can go and throw the file not found exception. So one of the way to mention is that in the method signature itself, I go and use a keyword called as throws, which indicates that boss, this method has a chance that it can go and throw the file not found exception. This is one way of doing it. Another way of doing this is you go back to the code, right? And here in this case, I go and surround with the try catch block. As you can see here, I've surrounded with the try catch block. So even before I'm executing this code, if I don't surround it with the try catch block, the compiler was throwing error. So whenever there's a checked exception, it has to be handled either using the try catch block or go and indicate in the method in which that code is written that this method can actually go and throw that given expected form of the exception. So this is my try catch block. So we have understood something called as throws keyword. Now let's try to talk about another situation where let's say that there's a method inside and we want to explicitly throw some kind of exception from it, right? So what I'm going to do now is that let me go and comment all this line. And let's say that I have a method called as validate public static void validate. And what I have to validate? I have to validate something called as age, int age. So you can say that if age value is less than 18, then what I'm planning to do, I want to go and throw the new exception, throw new arithmetic exception, and I go and say that not allowed to cast vote, right? And this I go and do. Otherwise, what I go and do, that says out, you are eligible to cast the vote. So in this method, when I purposefully, I want to do it myself, right? So I using throw keyword, I can go and myself throw a exception. When I go and make use of the throw keyword, throw is a keyword which is used to go and throw a new instance. New, this means this is the instance of exception. So what we have seen so far, we have seen a word called as throws. We have seen a word called as a throw. Throw is basically used to throw exception. Throw an instance of exception. Whereas throws keyword is used to as a method signature. Method signature. Fair enough. Now, if I go and call this method inside this function, let me go and call it validate, and I have something called as 20. If I go and run this, it works fine. You are eligible to cast the vote, but in the case of the age, I go and put it as 15 and run this. This will throw me error Java lang arithmetic exception, not allowed to cast the vote, right? So this code has started throwing me the exception. How do I handle it? Two ways to handle it. One, either you go and throw it using the throws keyword in the method signature of this main, or you go and handle it. So I go and handle it with the handle of the try catch block. So what I'll go and do, I'll go and say the try, and then I'll go and put this inside, and then I go and set that catch, and this was arithmetic exception, so I go and set that arithmetic exceptions A, and I go and set this as out, handled inside the catch block. Let's go and run this, handled inside the catch block. So this is how you can go and throw your own exceptions using the throw keyword. So let's do a quick summary of what are the things that we have learned so far. So far what we have done is we have understood the following concepts. So we have understood the concept of try. We know that with the try there could be multiple catch blocks. Catch, catch, catch. One try can have the multiple catch. We also made use of something called as finally. Alright. Finally is not a method, typically it's more of like a code block. Then we saw that there's something called as, if I have to go and throw something, I go and make use of throw, and then throws is used in the method. So throw is used to throw exception, throw exception instance. And throws, why do I make use of throw? Throws basically used in the method signature. Fair enough. Now since we've understood all these things, let's try to talk about that how the exception propagation happens. How does the exception propagation happens? Let's say you do it with the help of a code example itself, and it will make things pretty simple. So let me go to my Eclipse here, and let's try to remove this. Let's try to go and comment this up. Right. In fact, if I delete this. Now here, we're going to define a method called as void m, which is a method for int data equals to 5 divided by 0. I know that when I go and do this, this will lead to the arithmetic exception. Now I have another method called as void n, which calls the method M inside it. Then we're going to find another method called as void P, which calls the method N inside this. Right? And then let me go and put something called as static. And let's go and call this method P inside this main method. So if I go and run this code, the final exception here is showing is divided by 0. Java lang arithmetic exceptions. And where all the exception has happened? Exception has happened in the line number 8, which is here. Right? So if I go and talk about the call stack, right? So first of all, the exception happened at M. But since here it was not handled, it moved to the line number 12, which is here. So it went inside the N. Here also it was not handled, so it went to the line number 16 here, which is the P. Here also it is not handled, so it finally went to the main method. Main method at the line number 21, and after that the program halted. So when you don't go and handle the exception at the place which is handled, it gets to the calling method, and again if it is not handled, then we keep on going to the main, and then finally the whole program will be terminated. Now let's assume that at this point itself, I go and handle this exception. What will happen in that case? So if I go and do this, so I have try, I put this N inside this, and I say that catch. Sorry, it should be inside P method try catch block. If I go and run this now, what has happened? Exception first of all happened inside the M. It couldn't be handled, it went inside the N method. It could not be handled, it went inside the P method. Here it was handled. And since it was handled, it was not propagated to the main method. It didn't go to the main method. So this is how the exception propagation happens. So finally, we have completed day 24. It's a long streak now, and I believe many of you would have already gotten the confidence that we are moving in the right direction. Help me know in the comments that are you guys getting that confidence that they know the concepts to go and crack the Java interviews. Let me know what is your experience of the learning so far has been, because your every comment, I'm watching it, I'm reading it, and that motivates me to give 200% extra. I'll be waiting for your comments. And the next video, which is day 25.